Thank you, everybody. Again, thanks, Jenny. My name is Jeff Piach, and I develop large client-heavy web applications, and I'm also a YUI contributor. Now, before I get going here, is there anybody here that develops applications using a collection of frameworks versus just simply sticking with YUI? Anyone? Couple of us? Yeah, there we go. All right. And is there anybody here that has developed an application using just YUI and the YUI app framework? And a couple of them. OK, excellent. So with websites becoming more dynamic and responsive, and with the new industry of building web applications, we need to be better developers in a few key areas that we didn't have to be when web pages reloaded every time the user interacted with the page. Those areas are, we need to require standard development procedures. We need to develop with modular development practices and think of extensibility. We need consistent APIs. We need better documentation and proper testing. So you take all of these things and you combine them with a large distributed development team, a 12-month plus development cycle. And you've got a lot of new and exciting challenges to deal with that we've never had to deal with before as JavaScript developers, but other developers in other languages have had to deal with for a very long time. So generally, the standard practice when you start a new web page or web application is you reach for your trusty HTML template, which has your typical libraries already included into it. You head out on the internet and you grab your third-party libs. You throw them into that template, you write the glue code, and you ship it. And of course, this is a simplified example, but that technique works really well for small applications or small websites. But as they start to grow, they start to show you a lot of issues that used to be unforeseen. So why do we need standard development procedures? The reason is because we simply start to have issues with coding styles, coding standards, and coding practices. And this really starts to kill your productivity as your project grows and as your team grows. So how do we solve this? Well, a typical solution is to use a standard code style guide, and I highly recommend that everybody use one of these. But it does little to enforce things like API consistency and module or class organization, which of course, over time, your application just starts to grow and diverge. So what do you do from there? Well, you use a true JavaScript framework. So, and it sets all of these things up for you. You have class and module naming conventions, you have code organization, and you have extendable classes. So, a little story about this. Not too long ago, a friend of mine came to me and said, hey, I'm taking off for a few days, and my company doesn't want to stop development on this project. Can you help us out for a few days? So I said, sure, why not? And but as things go, I didn't end up getting the access to the database or the code database, until late on a Friday. So by this time, he's gone. I've got a list of tasks to complete over the weekend and have to have it back by Monday. So I was kind of like, oh no, what's going to happen here? But as I started looking through the code, I realized these guys used the YUI framework. They extended YUI core modules, and they developed with consistent APIs and conventions that have been set forth by the YUI community over the past few years. So with this, I was able to get up to speed on this project a lot quicker and without a lot of outside help, so that I was able to produce quality code for these couple days that he was gone and commit it, and then they weren't stuck with trying to fix my code or have someone come in on the weekend to help me out. So this is in contrast of a collection of libraries that generally have their own naming conventions. They have their own code conventions. They have their own organizational conventions. Then what generally happens is your team will build its own conventions on top of those libraries. And what this really does is it makes your whole project unintuitive for new developers to come on the team, or for developers from outside of your team to really come in and get familiar with your application quickly. So if you use a true JavaScript framework, you can do things like hire people on short notice. You're able to hire a contractor literally with hours notice and get them up to speed quicker. You can greatly reduce your educational expense, because right now what you have to do is you have to go and you have to take a productive developer off the line. You have to sit them down and do some pair programming or what have you with this new developer and teach them all of your internal conventions and your file structures and what you're trying to accomplish with this application. And you don't have to do that if you follow a framework's conventions. And this is also going to greatly increase your speed to your productivity, because these new developers aren't going to produce bad code. You're not going to have to go back and refactor it later on. So that's why we require standard development procedures. So modular development and extensibility. This is really only second to our previous point. But any good developer will tell you that you don't want to build large web pages or applications. You want to break them up into manageable pieces and then assemble them later on. And a perfect example of this in YUI is the Y.Panel widget, which I'm sure a lot of you are familiar with. But what you may not know is that it really has almost no code of its own. All that is really happening here is we're extending widget, for those that aren't familiar with the y.base.create method there. And we're extending widget here, and then we're mixing in all of these other extensions. Now, these extensions were actually written for other modules in the YUI library and written for completely different usage. But because they were written with extensibility in mind, we were able to take widget, mix in all of these extensions, and actually create an entirely new module out of that without doing any more work. So a great example of how YUI and its built-in extensibility helps you out is with the calendar module. So what we've got going on here is we are extending y.widget. So we have calendar, and we're creating the calendar base module, and that basically provides the base functionality for calendar. Then where we've got the ... there, that basically is adding in our own methods into the prototype for calendar base. So now this is great, but the calendar doesn't have a UI to it yet. So what we do from then on is we're extending calendar base for y.calendar. And then we're adding our own prototype methods into that one as well. So as you can see, we now have y.calendar here. We have extended the calendar base, which adds the calendar functionality, which extends widget, which adds our widget lifecycle, render, bind UI, sync UI, which I'll get to a little bit later. And because widget extends base and attribute and event, we get all of that functionality all off the bat without having to reinvent the wheel. So calendar is a great widget, and I use it quite a bit, but it's missing one key feature. And that is the ability to pop up when someone clicks on it. So kind of like a date picker. So I created this and it's for a project. Now, can you guys see that there? Let me just zoom in here. So as you can see here, we're using the y.base.create method again, and I'm extending y.calendar. So I'm actually taking all of the code that was in these objects before and extending that into my own widget. Then the really cool part here, though, is the y.widget position, the widget position align, and the widget auto hide extensions that we had previously mixed into panel, which were written for other modules entirely, which I'm now mixing into my calendar extension. or sorry, my new calendar module. And so what's really cool about this is that because these components were written, again, with modularity and extensibility in mind, we can add that functionality to our own modules without having to reinvent the wheel. And this maintains a consistent API whenever we do this. So going back here. So of course, though, when you are asked to develop a module, it's not very often that the client is satisfied at that one point. They generally decide to change the spec right after you've written all this code. So going on from there, the next task or next feature that needed to be added was what I'd like to call pop-up calendar group. And what this is it's essentially two date pickers, and it allows you to set an outer bounds on a lower and upper date. So what I did there to add this group functionality was, as you can see here, we're using the y.base.create method again, and we're extending y.base. So the cool thing about this is that the y.base module or code is already loaded on the page from the calendar and the panel widget that we were using previously. So we don't need to go and fetch more code to be able to add this functionality in. And because of the conventions that are built into y.base and the methods that it provides, it enforces a convention on the code that we write because it's providing us with things like initializer and destructor methods, so it's actually easier for us to use these provided methods than create our own. So again, it's just enforcing these conventions as your code grows. So, moving on. The YUI gallery. So after I wrote those two modules, I pushed those modules up into the YUI gallery, which we had talked about earlier today. And basically, again, it is a collection of third-party modules which are built on the YUI 3 framework. And it is all hosted on Yahoo CDN. So what this allows other developers to do now is to load the YUI calendar onto their page and add my functionality in for the pop-up ability or the group ability, and only take a very, very small K-weight hit on loading that extra code on the page because we're already utilizing a lot of these objects that were already loaded onto the page. So as you can see, extending components in YUI is hugely powerful. It gives you huge time savings because you don't have to repeat yourself. You never have to reinvent the wheel. It's also going to help you maintain an intuitive and consistent API, which as your project grows is incredibly important. And of course, it's going to give you some IE6 and up compatibility if your project relies on that, because the YUI framework for a lot of components actually has to support all the way back to IE6. So all these modules are great, but it really sucks to try and maintain all of them. Right? You have a huge collection of modules which are extending and extending and extending, but luckily YUI provides us with this amazing tool called the loader. Now, the loader, this is a very, very, very simple example of the loader, but just to give you a very brief idea as to how or what's happening here, the loader basically takes a list of modules that you want to load on the page, it references its metadata, and then figures out what its dependencies are, creates a concatenated URL up to a specific length, and then splits it up into the minimum amount of requests that are possible, and then requests those from your combo server. So what we're doing here is we're providing a custom module metadata into the loader, and we're calling it custom module. And the next two properties there are path and requires. So we're just simply telling the loader, hey, this is where this module is located, and these are its dependencies. So what we're basically telling it here is that, okay, it requires panel, and panel requires widget, plus all these extensions, widget requires that. So loader is smart enough to resolve all of those dependencies all the way down the chain. So the next interesting part here is the use, what we call the use statement. And this is where you load modules into your YUI sandbox. And so what we're basically telling it here is that we want the calendar widget and we want our custom module. So loader goes and it goes through its metadata, pulls in all the requirements for the calendar. It then runs over to the next line and says, okay, we need this custom module. Well, it turns out calendar already requires the majority of the code that custom module requires, so it simply just adds in the parts or the URLs that we need and combo loads them and then requests them from the server as a single request. So this really simplifies managing all of your modules and all your dependencies, so it allows you to actually get back to coding instead of basically babysitting your code. So what you next need, though, is to tell the loader this code needs to be loaded into the sandbox. And for that, we use the YUI.add method. Basically, what this does is it's just simply a wrapper around your code that you give it a name. At the bottom there where you see 0.1.0, you give it a version. And then you have a bunch of configuration information, such as Skinnable and the modules that it requires. And the cool thing about this is that if you forget something in your module configuration, which we saw earlier, then once the module is loaded and loader says, oh, wait a second, I've just parsed this, you actually needed more stuff than you told me initially you needed, it will go and make another request of the server to pull in that information. Now, of course, this is something that you don't want to do because it's going to incur another HTTP request and delay the execution of your application, but it's kind of a backup way just so that you know that your application is going to run and that your dependencies are going to be managed. So if you combine the consistent module development patterns with an advanced loading tool, you get a consistent application and consistently designed code. You get an intuitive code base, so you know where your modules are located and how to fetch them. And you also create very readable code because you're able to break it up into a lot of modules and know which or where your dependencies are located. Because what I've been trying to get through here is that modularity provides extensibility. And with YUI, the ability to extend things is hugely powerful. And one of the best things that I heard last year at YUIConf was don't hack, extend. And this is something that Derek Gathright said last year. And it's really true when you get these YUI modules because we're able to simply extend them instead of monkey patching in all of our fixes when we're using third-party code. So we've covered why we require standard development procedures. What modular development and extensibility is, and now consistent APIs. So I'm just going to grab some water here. Consistent APIs, as I'm sure anyone will agree, is important on applications of any size. But with these new web applications, of course, the application size is growing and growing and growing, and consistent APIs become more and more important. So to illustrate this, what is a consistent API? Now, can anybody tell me what the difference is in the execution of these two methods? That's kind of a trick question. There's no way that you can tell me from looking at this code how these execute. The first one renders to the DOM as soon as you call it. The second one actually waits to be requested again afterwards to render it to the DOM. So you compare this to the YUI modules, which because they're built on a consistent base modules and they were extended from those modules, anybody here is able to tell me that the top one simply creates a new instance of data table and that the bottom one creates a new instance of carousel and then renders it into the element. So this is great. Now, a perfect example of an inconsistent API are these two methods here. So these are two very popular modules from another library, and because the library doesn't enforce any conventions on the code that's being built, you can see here how these two very popular modules have two totally different methods for destroying themselves. So the top one, of course, fn destroy, and the bottom one, destroy editor. So the only way you know how to destroy these objects is by going to that third-party API over and over and over again to find out, hey, how do I destroy this? How do I init this? How do I render this? You compare that to modules that are built on top of the YUI base and YUI core framework, and because you're extending these modules, and it already provides things like the initializer, the destroy method, the render method, sync, bind, etc., you know that it's already provided there, so the developer is going to use it because it's actually more work not to use it. So you know, I have this data table instance. If I want to destroy it, I'm just going to call destroy on it. Same with the carousel. And YUI, because you're extending these base components, provides you with quite a few conventions. Just a couple of them, like I was mentioning, destroy, render, sync UI, bind UI, and properties, source node, bounding box, content box, height, and width. And of course, these go on and on and on and on. So to illustrate how these conventions are used, I just went to the YUI gallery and just picked a module at random. In this case, it's the y.spinner. So this is a module made by a developer on top of the YUI core components. And so what we can see here is that we're creating a new spinner instance. Now, if we want to provide information for the initialization of this from the DOM, we simply use source node, and then we render that to the DOM. Compare that to our previous y.panel core widget, which is, again, a core widget actually from the YUI team. We're following the exact same steps. We're creating a new instance of panel, and we're, again, providing it with a source node and width and height. So these are things where you can easily see now that a third-party developer can create modules following the exact same API as core components. So when you're using this developer's modules, you already know what the API of that module is because it's extending these components. So why consistent APIs? It's going to speed up your development, plain and simply because you already know how to use them. The code is easier to understand because, again, you have used these conventions over and over and over again in your own code, and it's going to remove those constant API lookups that you had to do when you kept referencing these third-party libraries. So that's why we require standard development procedures, why we need modular development extensibility, and why we need consistent APIs. So now on to documentation. So there's been quite a few talks about documentation and quite a few about testing, so I'm only going to touch on these briefly. But as anyone can attest, is that documentation is a laborious and tedious process that nobody wants to do, especially when we like to actually create code and create cool things. Now, YUI has an extensive API and documentation, which has taken those developers a very long time to make. But it's been made a lot easier by a couple tools. And those are YUIDoc and Celic. So YUIDoc basically allows you to generate API documentation on the fly as you write your own code. Just like we saw earlier in Tony's gallery talk, as he was able to write the code, he was able to document that as he went along. It works on any language that uses /* comment blocks, not just JavaScript. And it includes a standalone documentation server, which I believe Tony showed us this morning as well. Basically what that means is that as we saw, as you're writing your code, you can actually reference your own API as the code is being developed, which is hugely powerful, especially when you're working on a team of 20, 30, or even 100 developers. And this server that's provided to you for free gives you real URLs and graceful fallbacks for Spire-Silo JavaScript, which basically means you can be running a documentation server for your whole dev team, which is compiling the documentation for your API from each developer on your team as they're writing the code, which is hugely powerful. So just to kind of briefly go through the YUI doc example, which I mean we've kind of already seen today. Basically at the top we're providing the description for whether it be a method, a property, an attribute. In this case it's a method, which is called method name. We have a set of parameters, which are strings, objects, functions, etc. And then we have at the bottom there the what it is returning. So this particular method returns a Boolean true on success. So just to give you an idea about what that creates, so this is the code for the anim class on YUI. And simply just by using YUI doc and writing the documentation with your code as you go along, it actually generates an index of all your methods, properties, attributes, and events. And if you notice along the left-hand side here, over a large project, it actually maintains reference to all of your classes and modules. So this is great when you've got a framework, but just imagine when you have a 200,000 line application over a large development team, you can easily reference one of your other devs' API documentation while he's writing that code. And again, when you go through onto the methods section here, you can see we have the method name, the parameters that it takes, and also actually where it's even inherited from if it's been extended, and all of the description for those parameters. So to show you what the code looks like that was created from, you can see here that for an attribute, all you really need is a description. You need to say you have an attribute, which is simply called node, and it is of type node. And as you go along, you can see here we've got a little bit longer description, attribute, easing, type function. So as you're writing this code, you already know what this is supposed to be doing when you're writing it, so it makes it very easy to create this documentation as you go. And it's not a whole lot of work. You know, you don't have to write these massive paragraphs that are down here for your own personal applications, but it's really not a lot of work if all you're doing is writing a short description and a couple flags. So to move on is Select. So Select allows you to generate user documentation from Mustache templates. So we saw this talked about a little bit earlier as well with the gallery talk. It's a single line install if you wanted to run it outside of Yogi, which is simply npm install select-g. It provides CSS theme support so that you can use the exact same structure that's provided by the YUI documentation team, but you can just simply provide new CSS theming for it. So to give you an example of what that does for you, here's the documentation for data table, which I'm sure a lot of you guys have used. So as you can see here, we have this getting started here is actually a partial, as Tony had mentioned this morning. And you can embed code, you can embed images, etc. And what's really cool is that it'll actually generate your table of contents and example list all automatically. So it really pulls out a lot of the tediousness from generating user documentation. So back here. So we've run through why we require standard development procedures, why we want to think about modular development and extensibility, what are consistent APIs and why they're important, and how to simplify your documentation writing tasks. So on to testing. Now, of course, testing has been covered quite a bit, but it's also, as Reed had mentioned, it takes a very long time to write these tests, and it's a very tedious job to do. Now, and YUI has over 8,000 tests in their core testing suite, which obviously took them a very long time to write. And to make that easier for them, they created YUI Test, and of course Yeti, as Reed had talked about. So YUI Test is basically a testing framework for JavaScript that works in the browser or on Node.js. Simply, it allows you to rapidly create test suites, test cases. You can group them together with test suites. You can create mock objects so that you don't need to pull in external dependencies for your tests. And it allows you to do asynchronous testing for events and AJAX requests for testing your API along with your unit tests. It does cool things like DOM event simulation, so you can actually do gesture testing and clicks without having to rely on something like Selenium. And just like we saw with the earlier Yeti talk, test reporting can actually go to your local machine, which you're running the tests on, or it can be sent remotely to something like a Yeti testing server. So this is a basic test here. It's kind of condensed, but what you simply do is create a new test case instance. You provide it with a name, you give it a setup method and a teardown method, which basically says, when we start this test, these are the objects we want to create. When we're done with this test, we want to remove all those objects and events and stuff that we created so that the next test doesn't run into those issues. And then we have a bunch of named tests that follow, which actually are the tests that we're going to be running. So now Yeti, as Reed had shown this just a couple hours ago, Yeti allows you to run tests in multiple browsers at the same time from your own computer. It's, again, another single-line install. It's simply npm install-g and then this URL. It allows your browsers on multiple devices to report back to the server. And that basically allows you to have, just like Reed had shown us, a lot of devices basically spread out literally all over the world and have all of those test cases report back to your central computer. So in closing, reducing project development costs simply come down to maintainability of code and how easy someone not familiar with the project can get up to speed with it and be productive with it. By using a JavaScript framework like YUI 3 will give you the tools necessary to build well-architected software. And well-architected software allows you to build code that is reliable, it's provides great compatibility, extensibility, and maintainability because you don't know what you're going to be asked to develop later down the line. Sometimes you don't even know what you're going to be doing tomorrow because, after all, the only thing constant in web development is change. Thank you. So does anybody have any questions? Comments, concerns? Doesn't look like it. I have no idea.
The question was, what font is that? The answer was, I have no idea.
Yeah.
Well, thanks a lot.
Great, thank you.